finding the least common multiple, or what you normally hear most of us say LCM, of large numbers. I added large numbers to it because most of the times that is where the problem really is. So what is LCM? Now, from Form 1, or still we are in Form 1 anyway, so maybe we would have learned about numbers and how they are used, different types of numbers. We have odd numbers, even numbers, and multiples of numbers. Like multiples of every number is, if you start from a particular point, you keep on adding the same number to the point at which you started, and you keep on adding to the previous one, keep on getting new one, and you keep going higher and higher and higher. And we know this from childhood, when our teacher will ask us to be reciting the times table. Alright, yeah, so maybe 2 times 1, then we say 2 times 2, we say 4. It simply means that the first 2 that you add 2 to it, and let's see what you get. So it means if I give you 2 apples twice, how many apples would you have gotten? If I give you 3 apples, 2 apples 3 times, how many apples would you have gotten? If I give you 2 apples in 4 different occasions, and let's say that you store them in the fridge and you didn't eat any of them, how many apples would you have in your fridge? That is the multiples, the number of times I keep on giving you something in a particular number, group of numbers. So now the least common multiple deals with me counting a particular multiple and you counting a particular multiples. Now when we say something is common, it means it can be found in maybe more than one places. You can see the same thing here, and when you move to another place, you might happen to see it at that place also. Yes, so nowadays we can say that mobile monies are very common, because wherever you pass, you see somebody sitting behind a table or in a small kiosk and serving as a merchant, helping people to withdraw and deposit money. So it is common. Now the least common multiple is going to be broken down into the words that are actually in the phrase least, common, and multiple. So we start from the last one, which is the multiple. That is what I explained, that numbers, like when I multiply numbers by a certain value and I keep adding that same number continuously and I keep going up. It's like how we climb stairs in our house. You move like this, then the next one, then the next one, then the next one, and the higher you keep adding, keep moving higher and higher. Wonderful. Now the word common means something that can be found everywhere, or at least in particular places. Yes. So now let's add the common to the multiple. So it means if I'm counting a particular multiplication table and you are also reciting a different multiplication table, the answers that we are getting as a resultant of whatever we are doing, are we likely to have some numbers that are common in our results? Let's say that I'm reciting 2 times. I'm doing multiples of 2. So the first one is going to be good. I want to make it like a set. So the first one is 2. The first 2 is 2. Then if I do 2 times 2, I'll get 4. 2 times 3, I get 6. Then I get 8, 10, and I continue in that order. Let's add last one. I don't want to go off there. So then maybe 12, 14, 16, 18, that way, and it goes on and on. As long as you really want to go, you can still be going. Now let's say that you too, you are reciting another multiples in different number, say 3. So yours is going to be the same multiples of, but not 2, I think what? 3's. Good. So yours will be, the first number will be 3 times 1, which is 3. 3 times 2, 6. 3 times 3, 9. 3 times 4, 12. 3 times 5, 15. 3 times 6, 18. 3 times 7, 21. On and on and on, then you stop. Now let's just use only these 2. Now these ones are multiples of 2 different numbers. Now if I take this one that I did somewhere with nobody actually paying attention to, and this one that you did, which I wasn't paying attention to, at the end of the work, if we all present our work like this as a group now, let's look at what answers I had for my multiples and the answers that you have for your multiples. We can decide to check the answers and see if there is any number who happens to be here and at the same time here. Alright, so let's check and see if there's a number here and the number can still be found in this new set, which really have nothing to do with this one as far as this one is concerned, right? Now we can call those ones multiples or common multiples. This time, with respect to the 2 numbers that we are dealing with, of what? 2 and 3. Wonderful. So from this table, we can list them as what? We'll check this set and see if they have something in common. What do they have in common? I will use the marker to cancel numbers that can be found in both sets. So I see 6 here, and when I glance through this, there it is, another 6. So 6 is like a gossiper. He goes here to go gossip and he comes here to gossip, so he can be found anywhere. Yes. So what else? Now we see 12 too, and it's here. Then these numbers can be jumped because they are not in this set. So let's say which other number can be found in this set and at the same time in this set. This is Mr. 18. He's also here and here. Good. So I have cancelled 3 of them. So they become the multiples of these 2 numbers, the common multiples of these 2 numbers. That is 6, 12, and 18. Wonderful. Good. Then we move one step backwards as far as this went. So we go backwards. So we have done C and M. So first we did M, and we come to C and M. That is the common multiples, those that can be found in both sets. Then the last one is moving one step backwards to go to where the L is, which stands for the word least. Now what is the meaning of least? Least means the smallest among a group of people. So maybe if I'm sharing money for a group of people and I say the least that any of you can get is this, it means that is the smallest that I can give you. And when you get that, nobody can get below that number. So if the least I'll give you is maybe 10 cedis, nobody can get 9 cedis. Any other number that anybody will get will go beyond the 10 cedis that I've given you. So everybody is going to get, any other person will be getting from 10 cedis upwards, and nobody will get below that. So it means the least common multiple simply means that let's go to the set of common multiples and choose the smallest number among that group. Alright, so least common multiples of 2 and 3 is what? So first it was the multiples, then we came to common multiples. Now the last one is the least common multiple. So go to the set of common multiples and choose the least number there. So what is the smallest numbers in this new set that I got after I chose those intersecting guys that can be found, let's say those that can be found here and here. So I'm going to choose them. I chose all of them. I've written it here nicely. Now, who is the youngest among them? He will be the least number that we are actually looking for. Alright, that is what? 6. So I say the LCM of these two numbers is what? 6. What this means is that if I am reciting 2, 1, 2, that we know from class 1, and somebody is reciting 3, 1, 3, the first number that we will mention, which is common in both of us, our answers, is 6. You can try and see. So you will do 2, 1, 2, 2, 2, 4, 2, 3, 6. It means you jump 3 steps to get to that number. Now I will be reciting 3, 1, 3, 3, 2, 6. So it means I take only 2 steps and I get to number 6. But you will take 3 steps and you get to number 6. But the most important thing is that is the first number that is common to what we are reciting, because 2, 1, 2 and 4 are not common to your 3, 1, 3. Are you getting it? Alright. So the least common multiple here is 6. Now, this is a nice way of actually finding this, and it will surprise you how this kind of activity that you see here, which looks like it's nothing, helps in computer science. One day when you grow up and you become a computer engineer or something, you will realize how important these things are. So they are not just something that we learn and we don't use them anywhere, like our society makes us believe that when you go to school, the science and the maths that we learn, emphasizobia and so it is never